Welcome to the screencast for 6.1. So I'm splitting this screencast into 2 different days. And so what I want you to do is you're going to watch the screencast, you're going to try some of the problems on the 6.1 worksheet, and then we can come back all together. I can answer some questions, and then you'll watch the second screencast. My goal is to kind of slow it down just a tad so you aren't super stressed, right? You're going to watch a screencast so that way, you just listen to me go on and on when you're by yourself, and then when we're all together, we can actually do questions together. Also, if you have any recommendations for awesome albums you've listened to or any TV or movies, as long as it's not trash, think of my brother-in-law's password to his Netflix, Disney Plus, I have Hulu, and Amazon Prime. So open to suggestions. I just don't buy into the cable TV networks. Okay, so 6.1 slope fields. What the heck is a differential equation? So differential is like it's a small difference, right? It's a small change. And so things that are small changes are something like a du or a dx, right? Because remember, dx is a very, very, very small width. Remember when we were doing integral, something like, 1 dy. So this was the length, this was the width. All right, when we're trying to find the area under the curve, this is a very, very, very small change in width. Okay, so that is what's called a differential. So a differential equation is an equation involving a derivative. So the order of a differential equation is the order of the highest derivative involved in an equation. So if I have something like, dy dx is equal to, 5x plus 2, this is a first order, versus d squared y over dx squared, this is going to be blah, 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 right? That's a second order differential. So the idea is, right, for this first example, we want to find all functions that satisfy dy dx is equal to secant squared x plus 2x plus 5. Okay, literally, we're given the derivative, and what we're trying to find is all the y values, right? What is the equation? And then plus c. We're trying to find all the functions that satisfy it. So I want all the equations, and of course there's this plus c because remember when we talked about the derivative, if our derivative dy dx was equal to 2x, there's many functions that would be the antiderivative. There's many functions where 2x would be its derivative, right? Like y equals x squared, when you take the derivative, it's 2x. But also, you have when y equals x squared plus 2, y equals x squared minus 3. All of these have the same derivative. That's why we're looking for all functions that satisfy. So, in general, our function, if we're trying to solve this guy, would be y equals x squared plus c. C is just this constant, right? So we're trying to solve for the equation, so we have most of the meat plus a constant. Okay, if you think about what this looks like, looking at all these graphs, they all are the same shape. The difference is shifted up or down, and that's what this constant plus c is doing for us. Okay, so when I say find all functions, we're looking for, right, the part with a variable plus a certain constant. All right, so what we're going to have to do is, let me just rewrite it. I have dy dx is equal to secant squared x plus 2x plus 5. Okay, what I want to do is I want to split dy and dx. So it's very similar to what we were doing in 6.2, where, I had, u was equal to 2x, so du was equal to 2 times dx. How did I get the dx over here? Oh, okay. So originally it was dx, du, dx, because I'm taking the derivative with respect to x on both sides. And then I multiply by dx to get du and dx on split sides. So I did this on purpose because this lesson, we're going to have to split the 2 differentials. Okay. Multiply by dx on both sides. Multiply by dx. So you have dy is equal to secant squared x plus 2x plus 5 times dx. Okay, so far, so good. Now here is the trick. Here's the trick that we're going to do. Let's take the integral of both sides. Now, let me take this first part over here. I'm taking the integral of 1 dy. Well, technically, right? If you have 1, this is just, 1 times y to the 0. So what's going to happen is this is just going to be y plus c. Because we have to tack on a plus c because it's an indefinite integral. I'm going to name this c1 because it's my first constant. So I have y plus c1. Now let's take this part over here. Okay, so what function's derivative is secant squared? Oh, okay, so it's going to be tangent of x. And then add 1 to the exponent, divide by our new exponent. So 2x squared over 2 is just going to be plus x squared plus 5x, and then you have to tack on a plus c. So I'm going to name this c2 because I have 2 different constants. Just to make sure we're clear, so technically this was 2x, right, and x is the first, so I add 1, so that way it's squared, divide by 2, those 2's cancel out. Technically this is x to 0, add 1 to the exponent, so now I have x to the first, divide by 1, oh, literally divide by 1, it's the same thing. Now we just have to get y by itself, so I'm going to subtract c1 on both sides. So I'm going to let c2 minus c1 just be my big C, just a constant, because when you take a number minus another number, whether it's 5 minus 2 or 15 minus 25, literally all you're going to end up with is another constant, is another plain number with no variable. So I can write this as y equals tangent of x plus x squared plus 5x plus c. Awesome, and then that's it. So we're trying to find the general solution to the exact differential equation. So we have the general, meaning y equals something, right? Some function plus c. So first step, multiply by dx on both sides. So I have dy is equal to secant x tan x minus e to the x all times dx. Then take the integral of both sides. So I see this is just going to be y is equal to, okay, trick. The derivative, right? Secant x tan x is the derivative of what function? Because I'm taking the antiderivative. Or you could say, okay, well, secant of x, when you take the derivative, is going to be secant x tan x. When you take the derivative, when you take the antiderivative, that's what I mean by these arrows, right? I'm always very careful the way I talk about it because I don't want to confuse you guys. All right, and then the derivative of e to the x is just e to the x, and then there's this minus, so you leave it as minus in front. Because technically, if you take the integral of negative e to the x dx, right, there's that constant 1, so I'm going to bring the negative out. Oh yes, now I just have integral of e to the x, so it's just negative times e to the x plus c. So minus e to the x plus c, and that's it. But wait, you ask, what about on the left side? Right? Technically, this part right here is y plus c. But what we just did on the first part, in example 1, was I moved all of my constants on the right side, and it's just going to be another constant. That's it. I only really need to have the one constant, so I'm done. All right, let's try the next one. So notice x is greater than 0, and so we have to specify this, because if x was 0, this would be undefined, and that would be a point of discontinuity, right? And if it's discontinuous, you can't take the integral. Oh my god. Okay. So we specified, that way we know all the values we're plugging in won't cause us to be undefined. So our whole area where we're defined is going to be continuous. All right, that's why it's important. Multiply by dx on both sides. So I have dy is equal to 1 minus, let's see, 1 over x minus 1 over x squared times dx. All right. Yeah, I'm going to rewrite this first. So x, I'll leave this as 1 over x minus x to negative 2. All right, we're going to be taking the integral of both sides because we're trying to solve for y. What is the actual function whose derivative would be 1 minus x minus 1 over x minus 1 over x squared. So we're trying to solve for the function who this is the derivative. But the thing is, there's multiple functions where this would be the derivative. They all are just separated by this vertical shift. Okay, derivative integral on the left side is y. On the right side, okay, which function's derivative is 1 over x? Okay, so the antiderivative is ln of x, and since we said x is greater than 0, I don't have to put absolute value. The only reason we put absolute value because you can't take ln of a negative number. So we put the absolute value in case we had to plug in a negative x, but here we're only having x greater than 0, so I can leave the absolute value off. Okay, so add 1 divided by our new exponent. So the minus cancel out, right? Minus cancel out. And I have a plus 1 over x. And then, of course, plus c. Let's do another. All right, multiply by dt on both sides because that's our bottom differential. dy is equal to cosine t, e to the sine t, all dt. And we want to take the integral. Ooh, this is weird. This is hard, right? Because you're having a function times a function. But here's the deal. We have a function inside. It's literally I have e to the x, but I'm letting x be sine of t. Right? So I have a composition of functions. So you must use u substitution. Right? So u is equal to sine of t. That means du is equal to cosine t dt. And lucky for us, that's exactly what we have, cosine t dt. Okay, so I have y is going to be the integral of e to the u du, right? Because the highlighted portion, this is u, this highlighted portion is going to be du. So it's just e to the u du. Okay, so this is just going to be y equals e to the u plus c, but then we must plug back in what our u was, right? U was sine t. And then we're good. Awesome. Let's see. So I'm going to stop the screencast here because it's already 11 minutes. But, ooh, that's 3 pages next time. But that just means the screencast is going to be a little longer for our next class, just to prepare for that. So I'll be uploading the second screencast hopefully sometime tomorrow, which is Friday. If you wanted to like watch it ahead of time, it might be like a 20-minute lesson, just because I'm trying to anticipate any questions you may have. So I really want to like go through this slow. All right, have a great rest of your day, and try the 6.1 worksheet. You're not going to be able to do all of it, but you should be able to do at least the first 4 questions. Nope, I'm looking at the wrong thing. You should be able to do the first 4 questions on the worksheet. And then the rest of the worksheet will be, the rest of the worksheet is the next screencast. Awesome. All right, I'll talk to you guys later.